What is up, kabsat? So, eto na naman tayo. Magsasolve ng isang daily problem by lads Engi-Math scribbles. So, for today, we have the second problem and it's about fluid mechanics. Yan. So, it's all about laminar or turbulent flow actually, no? So, those are two types ng flow ng isang fluid in a given medium wherein malalaman natin kung gaano ka-turbulent or ka-stable or sabihin na lang natin kung gaano kagulo or kalma yung flow ng isang fluid. Kasi, diba, for example lang naman, pipes, of course, no? Very basic example sa pipes. Tapos, let's have a figure sa isang portion sa loob ng isang pipe. Okay, pagpasensyahan nyo na yung drawing ko. Alam nyo naman ako, masyadong maganda mag-drawing. Okay, so, yan. Nag-cut tayo ng dalawang cross-sections sa isang pipe in order for us to analyze the flow of a given fluid. So, ganito ang itsura ng particles kapag laminar. Yan, pag ganyan. Very smooth. Very calm. Yan, di ba? Parallel to each other. And laminar ang tawag. Oops. Laminar ang tawag sa... Alright, sige na nga lang. Mali yung pangit ng sulat ko. Anyway, so laminar yung flow nito. Okay? But, what if... Ano yung magiging itsura kapag turbulent? Alright. Drawing ulit tayo ng napakagandang drawing. Yan. So, kapag turbulent, right? Diba pag narinig natin yung word na turbulent, magkakagulo, gano'n, parang hindi siya predictable. So, from that term itself, no, ang turbulent flow, hindi talaga predictable yung flow ng bawat particle sa ating fluid na gumagalaw. So, parang ganyan. They cross paths every now and then. Yan. Mga ganyan, no? Basta, importante, they still flow on a given control volume, no? From left to right to left. Basta isang direction lang, pero along the way, hindi predictable kung saan sila papunta, yung mga particles. So, either, basta the paths cross every now and then. And, to quantify this given thing, no? Meron tayong tinatawag na Reynolds Number. Reynolds Number. Okay? And the Reynolds Number is actually the ratio between the inertial forces and the viscous forces. Diba? Inertia forces and the viscous forces. So, ibig sabihin nun, yung forces due to the inertia or more of the weight, more of the kung gaano kabilis ng flow nung isang fluid, nakadepende doon kung laminar or turbulent yung isang fluid. Also, for the viscous term here, ibig sabihin kung gaano kalapot, ganun, or more of kung gaano ka-resistant yung isang fluid in changing its shape, no? Syempre, 'di ba, pag gumagalaw naman yung fluid, syempre yung forces in between particles yan, it may cause the change in the shape or what yung sa flow ng water. Essentially, kung hindi nyo ganun naintindihan. Pero the Reynolds number, this will give us more of a hint kung ang flow ba natin, we expect it to be laminar or turbulent. Alright, and if you try to derive this one, yung inertia over viscous forces, we end up with, actually ito yung kanyang yung formula. It's velocity times diameter over the viscous forces. The viscosity, kinematic viscosity. Okay, so V is the velocity, D is the diameter of the pipe, And nu ito, is the viscosity, kinematic viscosity of fluid. Okay, and then, masasabi nating laminar yung isang flow if the Reynolds number, hindi talaga siya yung value, yung limit na to na value, hindi siya yung exact na value. It's more of an approximation, but in most books, ito talagang ginagamit. It's less than 2,000. Yan, yung limit. And it's turbulent if it's greater than 2,000. Although, there are also books na nagsasabi yung mayroong transition zone. Kaya minsan, yung 3,000, dun pa nagiging turbulent. Ganun. Pero yeah, in this problem, for discussion purposes, gawin natin 2,000. Right. So, well, at critical velocity, ibig sabihin kung kailan yung very critical yung flow. No, hindi natin sure kung kailan. Parang on the verge of being turbulent yung ating flow. So, equate na natin sa 2,000 yung Reynolds number, di ba? Pero problema, may V, may D. Ano ba yung nasa given natin? We have the kinematic viscosity agad, no? Meron nang given na nu, that is 1.5 times 10 raised to negative 6 square meter per second. And it's flowing at a rate of 40 liters per second. Or that is the Q, or the discharge. 40 liters per second. Pero you can convert this one into cubic meters per second for convenient computation, no? That's 0.04. Wait lang, double check ko lang. Yes, it's 0.04 cubic meters per second. So, kailangan natin kunin yung kailangan natin kunin yung velocity, tas ang hinahanap diameter. So, we can use the formula for discharge, and that is Q equals area times velocity. But what is the area of a circular pipe? Diba? Circle, pi over 4 d squared times the velocity. So we have 0.04 is equal to pi over 4 d squared v. We try to solve for v, of course, in terms of d, diba? And the value of the velocity here is 0.16 over pi d squared. Ngayon, doon na natin isa-substitute dito sa n sub r. So we have n sub r, that is 2,000, equals, what is the velocity? Okay, ito muna, wait lang yung 2,000 na to, unitless. Kasi it's a ratio. So, unitless yung ating 2,000 dito, kaya wala akong nilagay na units. And then for v, that is 0.16 over pi d squared. Ang units netong velocity natin, that's in meters per second, Yan. And then, for d, the diameter d, times d, all over the kinematic viscosity, 1.5 times 10 raised to negative 6. That is in square meter per second. So, if we try to analyze the unit, yan, yung velocity dito is in meters per second times the diameter na naka-meters divided by meters squared per second. Magka-cancel yung mga units. Yan, unitless. So, therefore, ang masosolve nating value ng d dito is in terms of meters. So, ang lumalabas na value ngayon ng ating diameter is 16.9765 meters. Wow, 'di ba? So ano yung pwede nating makonclude dito? Sige, para lang may maibigay tayong final answer, no? Okay, so para may maibigay tayong final answer, gawin natin in millimeters. Ayan, so rounded off to the nearest millimeter pa to. So times 1,000 mo to. Kasi nga, 'di ba, in 1 meter there are 1,000 millimeters. Right? So, ang magiging final answer natin dito ay 16,977 kasi rounded off to the nearest millimeter in millimeter. So ano yung pwede nating makonclude dito? Meron nga tayong sagot, kaso it's impossible. Diba? Napaka-imposible na mangyari yung ganito kalaking diameter ng isang pipe. 16 meters, unless it's very, very idealistic. Ewan ko. Diba? If you try to search it in Google, no, the largest pipeline, largest diameter of a given pipeline is actually, wait lang, i-google ko lang, very very slight, 457 millimeters lang. This one is 6,000 millimeters, 16,000 millimeters. So, di ba? Very impractical. Kaya, so, kung pag kunyari, yung tinanong sa problem, ganito, tapos, in real situation, ganito yung pinasolve, sabihin mo, it's very impractical. Di ba? Imposible ang mangyari to. Bakit nga ba nasabing imposible ang mangyari to? Kita natin, no? Yung kinematic viscosity, it's more of usual value. But for the discharge, 40 liters per second, that's very large, no? In terms of talking about yung discharge ng isang volume, ng isang fluid. 40 liters per second, parang imaginin mo, 40 na malalaking soda bottles. Diba? 40 yan. Bawat segundo. Isusupply mo yan. Tapos, yung viscosity medyo, medyo, not so high. Pero, still, diba? Merong 40 liters per second. Very impractical. So, anong point ko dito, we just solved this by for mere discussion purposes. So, naipakita ko lang guys na ayun nga, to have the flow critical, no, yung ating Reynolds number must be on point na dun sa may limit between laminar and turbulent. So, yun, no? Ano yung kahit paano natutunan natin today? Reynolds number, that is the ratio between the forces, the inertial forces and the viscous forces in a given flowing fluid. And then, yung laminar flow, wherein the path of the different particles of a moving fluid parallel to each other. And then for the turbulent, laminar muna. Yung sa laminar, very predictable yung flow. Okay? You can search a lot of things na videos sa YouTube or in other parts of the internet. You can search for very satisfying videos on laminar flow. Turbulent flow, ito yung mas nakikita natin everyday. The sky, the flow of water in your faucet, diba? Turbulent flow. The paths cross every now and then. And of course, the Reynolds number for laminar is less than about 2,000. Turbulent, more than 2,000. And then, yeah. So, kung hindi natin, etong VD over nu is for pipes only. Ha? Pipes lang yan. Circular pipes. Yan. So, yeah, that's it for me today. I hope may natutunan kayo. And that's our answer for this second problem. I'll see you on the next one. Link in the description below sa mga gusto nyong i-visit na sites. You can also follow me in another YouTube channel. Link in the description. Follow me on my social media. And you can also join us in our Facebook group and Discord group. Nasa description din. And you can support the channel by looking at the description. So, yeah, that's it for me. And thank you for listening. Have a good one.